Good morning, Algebra 1. Hope you guys are doing well this morning. Um, so today we're going to cover lessons 25 to 28, our week 7 supplement, and you guys will be doing exam 5 at home. So nothing out of the ordinary, right? And we're going to start with our supplement first. So just to refresh, right, we were learning about slopes. So let's go ahead and scroll down. We'll say we're starting at week 7 supplement. All right, so week 7, and so previously, and I guess I can spell this out here. Previously, we were talking about plotting some points on lines and all that sort of thing. So when we had last week, we were given points, right? So say we're just gonna make it simple here, but if I was given the point is 0, 0, right? Then that means that both of these things, right, are x and y here, but that means that my x is 0, my y is 0. And if I was given here where I had a 2 for my x here, and then, for example, I was given 3 here for my y, right? So this would be my x value here first and my y value here. And so last week we were looking at slope, and we said, okay, m is what? Well, it's my rise over my run, right? And we had a couple different ways to write this as a formula. I said, well, you can do it multiple ways, right? You can just look at the numbers, or you can plug it into a formula. But if I look at the change from this first point to the second point, what do I notice? Well, my rise is my change in y, right? Because if I have my graph, so let's put a little tiny graph here, that way we can see it, right? So I'll do that in red here. I have my little graph here, and I say, okay, well, I have my graph here, and I'm talking about, so whenever you make a graph, make it your practice that you write x here and you write y here, okay? Because that'll come up a lot of times, right? You have an x-axis and you have a y-axis. So our rise, as you can see, would be our change in our y value, and then our run would be our change in our x value. We always think about moving from left to right. So if I'm going to write my rise over run here, I say, well, how much did my y change from this first point to this second one? Well, it changed by 3, right? So I can put 3 here, and then it changed run-wise by 2. So I can say 3 over 2, just like that. Okay, so that's a little review of what we've been looking at here for slope. So now let's go ahead and go to our topic for this day here. So we had, let's go back to blue here. So we're talking about graphing a line that's in this certain form here. Okay, so this form is called slope-intercept form. So slope-intercept form. So it's a slope-intercept form. Okay, and it looks like this. So you say y equals mx plus b. All right, so hopefully this looks a little familiar, or at least some of it does, right? Because we just talked about our m up here, right? We said, okay, well, m is our slope. So we can label this and say, okay, this is our slope. This follows along with what we said on the top here, right? We said slope-intercept form, okay? So that's a slope. And then this we call our intercept, but it's not just any intercept, but this intercept here is our y-intercept, okay? So it's called slope-intercept form, but if I was going to label it more appropriately, I'd actually say it's my y-intercept. All right, so now here's the illustration here. So if you think about a graph here, okay, so you make a little graph here on your page as well. If you have a graph here, and you have x here, and you have y here, if you're talking about a y-intercept, think about football, for example, okay? If you think about football, well, what does an intercept mean? An interception, right? Interception is where somebody stops the ball, right? And they take it from where it was supposed to go. So if I have this line here that's in blue, and it's going from the bottom left to the top right, well, it gets intercepted by the y-axis here, right where it crosses. Right, so this is my y-intercept, and I can label it as b, right? And then I can say what that number is. So, for example, for this one, I don't know what it is, okay? But let's just say, for this case, we'll just say b is 1, for example, okay? I don't have any other numbers on here, but we can just say, for example, that it's 1, okay? And then for this one right here, we could also say, well, let's just say that, let's put some labels on my chart here. And so that's b is 1 there. Now let's think about this. So if I have -2 for my number here, -1 here, what axis is this that I'm labeling here? Well, it's my x-axis, right? See that, right? It's my x-axis right here. Oops, there, x-axis, right? So if I'm going from -2, -1, and then what's this along this axis right here? Well, that would be x is equal to 0, right? So now I can start writing out my equation for my line and say, okay, well, I was already given a couple of these things. So I say, okay, well, y here, and it says equals, well, it's mx plus b. Let's see what we can do for our b. We already said our b here is equal to 1, right? So we can kind of fill this in and say, okay, well, this is plus 1. Okay, you guys see that? Right, if I go back over to my graph here, that's where my line crossed the y-axis. So that's going to be 1. Now let's think about m, right? So my m is my rise over my run, right? So if my m is my rise over my run, let's think about this point here. Let's think about, I'm just going to see that dot there, x equals -2. I'm just marking it there, right? I'm right there. What happens if I go up from that point? So if I go up from this point and I go to the next point, then I say, well, then that means that I'm going to go up by how many? Well, I'm going to go up by only by +1, right? And then if I go over from this point and I go over to there, right? This is not a super neat graph here, but if I go over there, that means that my x value changed by 2, right? So it changed by +2. So 1, 2, right? That's rise over run. So that means that my m is 1 over 2. So then when I fill in the rest of my equation here, I can say, well, that means that I have 1/2, and I guess I'll go back to my x here, and say 1/2 x plus 1. Okay, so that describes that graph right there. Now we can go and we can look at the example on our supplement there just real quick. So that one, they plotted the graph. So I'll plot it real quick for you. And you can do it on your paper, right? So it's always good to do it on your own paper because then you get a lot better idea of what's going on with the problem. So let's make my x-axis a little bit lower here. Let's put my x-axis down here. So go ahead and start labeling. So this is x, this is y, okay? They went up to +4 here on the y-axis. So I went 1, 2, 3, 4. It actually went farther up, right? I'm going to go to 4 here, and then I'm going to change I'm going to mark my x-axis to 1, 2, 3. Okay, so I'm going to do 1, 2, 3, and I'm going to label this. Okay, it's always good practice to label your numbers here. Okay, so then I have 4 here, and I could label a couple of these here, but I'm not going to label every single point, right? I just maybe label my high numbers and my low numbers. Okay, and then they had a point here that was right. I'll change my color here. Yeah, this point here that was centered right here. See that in that kind of yellow orange there, that mustard color, right? It's there, and then they had another point where I was at 3 for x and I was only at 2 for y. So that means that'd be right here, right? You see that on their chart too? Okay, and then they had this other point up to the top left as well. I'm not going to plot that one right this second. You guys can look at that one yourself. But I had this line then that went like this, right? I had this line that goes from top to bottom like that, right? Or from left to right, I can see it's coming from top to bottom. Okay, so now if I look at this and I say, well, let's go ahead and label this as a point, right? Or label this, or make this equation here. And then I say, well, I know I have my slope-intercept form. It's y equals mx plus b. So I need to figure out what my m is and what my b is. Oh, going back to a football illustration, right? My b, I know is my y-intercept, right? So that means that my y is going to be intercepted by the line at some point here. And my point here is actually what? Well, you see it right there? It's 4, right? It's crossing at 4, so I can say plus 4, right? If it was negative, then I just say minus, right? Okay, but plus 4. And then my x is still x. Now I got to figure out my m. So my m, then I say, well, what's my rise? What's my run? Okay. Well, my rise here is a little confusing if you overthink it, right? And be like, okay, well, what's my rise from this point here that I just pointed to with the blue arrow, and down here, this is my other point, right? Well, if I'm going from 4 and I'm going down here, what's my rise? Well, it's not 2, right? It's going to be minus 2. Okay, and then what's my run? Well, I'm going from this side to over here. So my x value here where I started, from this right here, that's at x is equal to 3, right? I mean, x is equal to 0. And then I went over to x is equal to 3. So my run is my 3. So then my m here, if I want to put it right here separate, like I said, my m is minus 2 over positive 3. So then I can finish my equation up here, and I can just say, okay, that means that y is equal to minus 2 over 3 times x plus 4. Okay, and I can plug in some values for this as well if I want to. But notice, right, if I set x here, right, see this x right here? If I say, well, let's plot x is equal to 0, say, well, that means that I do y equals minus 2 over 3 times 0, right? Then I have what? Well, then I have, the only thing I have left here is plus 4. Okay, and then I just have y equals 4. So where is x equal to 0 on this graph here? Well, x is equal to 0 anywhere along this axis right here, right? So I plot x equals 0 there, and then my y would be equal to 4, which is this first point right here that I already pointed out right here in this, right? You see this? Right here, right? So you can see I plug values in there, but this is my way of easily finding it, right? And then I know that my minus 2/3 is my slope, so I say, okay, well I have a point to start. My point to start is right here, and then I know that I can move on my graph by going minus 2 plus 3. So I went minus 2 plus 3. Now if I want to go backwards, I just reverse it, right? So then instead of going minus 2 plus 3, I would go what? Well, it's like I'm seeing a minus m here, okay? Then I go positive 2, positive 2, and then I do minus 3, okay? So you can see on their example there, they did that same thing. They went up by 2, so let me see if I can draw this on here. Maybe I should have made this bigger in the first place, but you can see then I do minus 2, and then my point would be up, right? I'd go up 2, and then I'd go back over here, and my point would be, let's see if I can do my mustard color here, right? And be right there, and then I'd go and I'd follow my line there. So on their graph there, they just want you to plot as many points as you can on that graph there using both of those things. So the first step here, right, and they actually put it on chart there, whoops, they said, well, go ahead and plot your y-intercept first, right? They said, okay, you can graph your y-intercept here, right? This y-intercept, and do that. And then you go ahead and move by using your slope m right here, right? Your m right there. So that's the basics of that. So I'd encourage you to just maybe pause the video, and then you can go to and then you can continue watching the video after you've done a couple and you think you understand those, right? Always ask questions if you have any questions over that. But that's it for our supplement there. Okay, so on to lesson 25 here. So lesson 25 is about solutions of equations. We've done a little bit of this already, so it's not completely new here. I can put this up here. So solutions of equations, lesson 25. Okay, solutions of equations. Okay, so we have solutions of equations here. All the rules that we've already learned still apply here. So really, I don't think there's anything very new here. But let's think about this one. Let's talk through it. So we have example 1. We have 4x plus 5, and it's equal to 17. Okay, got that? Okay. So in the past, sometimes we'll just look at it and say, okay, I know what the answer is, right? We can't always do that, and so then we have to think about how to solve this. Well, our first thing to solve this, and we're like, okay, well, I haven't isolated my x. So anyway, let's review here. So if I have 4x plus 5 equals 17, what does that mean? Well, it means that I'm doing 4 times x plus 5, and then I'm getting 17. So like I said, equations mean that I have the same values on both left and the right side. So if I want to solve this, and I say, okay, well then my x is not isolated, right? So if my x is not isolated, I have to isolate it. So I have plus 5 on this side. Let's subtract 5 from this side, right? If I subtract 5 from that side, it's no longer equal to this right side of the equation, so I have to say minus 5 on both sides. Now, what do I have on the left side? Well, I just have 4x, or 4 times x, okay? And then on this side, I have 12. Now, what do I do here, right? I subtracted 5. Now I have 4 times x, and it's equal to 12. Now it's just identifying, well, if I have 4 of something, right, then to not have 4 of that something, I have to divide by that number, right? Because I'm doing 4 times x. The opposite of multiplying is dividing, so I can divide 4x by 4. And if I divide this side by 4, it means I have to divide the other side by 4. Okay, so then I have 4x equals 12 before, and then I had divided by 4, so that means that I just have 1x, right, because I divided 4 by 4, so this canceled. So I have 1, I can write 1x if I want to, or I can just write x. 1x is equal to 3. Alright, now let's look at our example 3, which is a little bit more complicated, okay, because it involves negatives. But I have, for example 3, I just have minus 7 times k, and then minus 4, it's equal to minus 21. So a lot of negatives going on here. Okay, don't let it confuse you. As we talk about negatives, negatives are just opposites of the positive numbers here. Okay, so you can do this multiple ways, right? I could, if I want to isolate my k, I can move my k to the other side so it's not negative. We're just going to go ahead and do it the typical way that we just did the last one, right? So we'll say, okay, well, if I have minus 7k minus 4, I don't want a minus 4 here, so the opposite of minus 4 is plus 4. So I'll say plus 4. Okay, if I owe you $21, right, and I give you $4, I still owe you money, right? I still owe you $17 or minus 17. And then on this left side of the equation, I have minus 7 times k. Okay, and now you get to this step and you say, oh no, I don't have I can't divide that. Well, yes, you can divide it, right? We can divide it. It's just not going to be a whole number, unfortunately, right? So when I solve this now and say, okay, well, I have minus 7k equals minus 17. I don't really like this, okay? Might not be the most neat. It's not the neatest answer here, but I divide this side by minus 7, right? Because minus 7 times minus 7 would be 1. Okay, and then I have to divide this side by minus 7 as well. Okay, so now I have k on this left side. If I divide a negative by a negative, okay, we're talking about in one operation here, right? I'm just dividing these two numbers, then both of these become positive. So then I'm left with 17 over 7, okay? And so when we think of negatives, right, they're opposites. So it's like if I say I'm not doing something, right, then I can say if I'm not doing something, that means I am doing it. So you can think of it that way, right? A negative divided by negative, that's two negative signs, and so we're going to get a positive. So I end up with k is 17 over 7. All right, last example here we're going to talk about would be clearing fractions out of a answer here. So if I had example 5, okay, so example 5, I have 1/5 times m minus 1/2 equals 3/4. So at this point you're like, oh, I mean I could add, right, if I want to isolate my m, I could add 1/2 to both sides. I can certainly do that, okay? The other way I could do this would be to convert these to decimals, and then I could solve it that way, okay? So let's think about this. If I have 1/5 m minus 1/2 equals 3/4, I want all the denominators to be the same. What is a common denominator for all of these? Well, 5 right here and 2, they don't go into each other, but 10 would go into them. 4 over here, right, doesn't go into 10, so we got to think of something else here. So if I think about this, well, 20 would work, right? So 20 would work for all of these. So then I say, well, I could multiply all of these by 20, and then I could work that out. So I don't know if I'd say the LCD here. So that would be the LCD. So I'd say LCD for the denominator is 20. Okay, this is only one way of solving this. I could always solve this the typical way we're solving these other ones, right? By doing my fractions. Well, let's do it this way. So we'd say my LCD is 20, so I can multiply both sides by 20 over 1. Okay, so if I multiply by 20 over 1, it means I multiply each individual one, right? So then I'd have 20 m over 5, and then I'd subtract 20 over 2, and then I'd have over here, I'd have 20 times 3, which would be 60 over 4. Okay, now if I write this again and say, okay, well 20 divided by 5, what is that? Well, that's 4. So I could just have 4 times m, and over here I'd have minus 10. Over here I'd have 15. Okay, and the reason I can multiply by 20, what is the reason there? Maybe think about it for a second. Well, if I multiply everything on the left side and the right side by 20, I'm not changing anything really, right? Because that means that if I am holding something in either hand, right, and I'm multiplying one side by 20, as long as I multiply the other side by 20, my equation is still equal to the other side. All right, so now we're going to solve this now. So we clear our fractions by multiplying by LCD. Now I'm going to say, okay, well then I'm going to isolate. So I say plus 10, okay, and then I'd have 4m equal to 25. So 4m is equal to 25. Then if I'm going to solve for my m. Okay, you can see the book solved this a little different way, so you can see what they did. Right, but I'm going to solve this by dividing by 4 on both sides. Right, any number. So let's pause. I'll say it slower. Okay, any number divided by itself is 1. Right. So if I have 4 times m, I can just divide it by whatever number's in front of it to make it just a single m. So a single m, and then it's equal to 25 over 4. Okay. All right. And last example here is example 6, at least the one I want to mention here. So example 6, 5 example 6, I actually have, I'm having decimals here. So decimals are, in general, I'd say they're not as hard to work with as fractions because you can directly add those. But if I wanted to get rid of my decimals here, right, you could just add 0.2 to the other side and then multiply, right? But if I want to get rid of my decimals, then I say, okay, well, let's think about decimal places. What do we know about decimal places? Well, if I multiply this 0.4 by 10, that means my decimal place would move over by 1, right? And I'd have 4 times x. So I have to look for how many decimal places I have in all 3 of these numbers here. Well, one that has the most decimal places is this one right here, 0.16 or negative 0.16. I say, okay, well, to get rid of that one, I have to multiply by 100, right? Well, then I can multiply both sides by 100. As long as I have both sides by 100, so that means that this over here is going to be 40 times x. This one right here will be minus 20. Then this one over here will be minus 16. Now I can solve here. Now I can say, okay, isolate my 40x, so I'll do plus 20 over here, do plus 20 over here. Okay, now this is where the negatives, you got to be careful with your negatives, right? If I owe you $16, right, and I give you 20, now I give you $4 extra, right? So 4. So then I have 40x is equal to 4. And then to find my x here, right, what do? Well, I have 40 in front of my x, so to get rid of it, or to find one of x, right, then I divide by 40. So then I divide by 40 on both sides, which gives me x is equal to 4 over 40, which, what does that simplify to? I can reduce it, right? What can I reduce to? Well, 4 goes into both of them, so I'd say 1 over 10. Okay, and that would be my answer. All right, and I think that's it for 25. So if you want to pause the video, that'd be good, and then you can move on to lesson 26 when you finish those and you see if you have any questions, okay, that you want to ask. All right, so lesson 26 here, we have similar equations here that we had in our last lesson. So lesson 26. Lesson 26, we'll just say, I don't know, they're multi-step equations. Multi-step equations. Okay, so if I have multi-step equations, I'm talking about pretty much similar things to what we did in the last lesson here. But now, let's write out example 1, and I'll write some tips here for you guys. Okay, so if I have example 1, and I have 3x minus 4, okay, and then I had it equal to 5x plus 7. You see, it looks a little bit, just looks a little more confusing than my last one. So here, I might say, well, why don't we assign one side to be variables, one side to be constants? Hey, what is a variable and what's a constant? Well, if we remember back to pre-algebra, we talked about these more, right? What does this mean? Well, it means I'm doing 3 times x. So this is my constant here. My 3 is my constant. My x is my variable. Okay, do I have another variable? Yes. Another variable here is x on this side, and I'm multiplying it by 5, right? So those are my variables, And then my constants, right? My constants are these numbers, right? So I have -4 on this side, and I have +7 on this side. So I might start by assigning terms and constants to either side. So say, okay, assign sides to constants and variables. So assign sides for constants and variables. Sorry, my handwriting with this thing is not as neat, maybe. Okay, but assign sides, I said side, but sides for constants and variables. So let's just say I want my variables, I like my variables to be on the left side in general. But what do you see here? I see, well, I have a 3x on this side and I have a 5x on the other side. If I take 5x from this side, well, that'd be a negative. That's okay though, okay? So now I'm going to say, okay, well, this side I'm going to say is my variable side, okay? You see that? And then this side is where I'm going to put my constants. Okay, so I can't combine anything right now, right? I actually have no like terms on either side, but if my variables and constants are there, let's change back to my blue color here. So I want my variables on the left side, so that means that I can subtract 5x from this side, right? Because my 5x, if I don't want it, then I have to do the other side. So then I'll write it underneath my 3x here, and I want my constant on the left side, so that means that I'll say +4 here, and I'll say +4 over here. Okay, so now if I add these things up, say, okay, well, if I had 3x here and I subtracted 5x, it's just like I had $3, okay, and I subtracted $5, that means I have -$2. So I have -2x, and then I did -4 + 4, so I don't have anything else left on this side. So I can say, okay, -2x equal to, and then I had a 7 over here and a 4, and right, I got rid of my 5x and my -5x, they cancel out. So now it's equal to 11. And then I do the same thing that I was doing in the last lesson, right? If I have -2x and I want single x, I divide by -2. Okay, so I have 11 over -2. So that means that if I want to write it out finally, right, I just say x equals, I could say 11 over -2 if I want to, but it's the same thing as saying -2 over 11, okay? That's typically how we'll write it, but it really is the same thing, right? Because if I think about 11 divided by -2, right, that would be a negative number, versus if I do -2 divided by 11, whoopsie, I wrote them in reverse order. You guys see that? I wrote them in reverse order, so okay, minus. Hey, I wrote in reverse order, but this one is still the same thing as it is above, right? Sometimes you get a little tripped up when I'm talking and write at the same time, but it's -11 over 2, right? That's the same thing as if I wrote 11 over -2, right? Because 11 over -2 would be -5.5, and if I do -11 over 2, it'd also be -5.5, okay? So you can double check this with your calculator as well, just to see how it works out. Okay, so that's that example there, and let's go to our last example for this lesson here, where we're going to combine on each side before we can solve the equation. So this is example 6. Okay, now if I have 2x here and I'm subtracting by 5, and then I'm adding 7x, and then on this side it's equal to 5 plus 3x plus 10. Okay, now I can see that I have some like terms here. So let's go ahead and highlight these. So talk about variables and constants, right? Well, I have 2x on this side, so I have 2x and I have another x term here, right? I have 2x, and I have plus 7x. And it's important here to include your plus or minus before your number, right? So for 2x, I don't have anything before, which means that it's positive. Okay, I don't actually have anything else to combine on this left side of the equation. But let's look at the right side. Well, I don't have any. I have a single x term, right? 3x. But I have this 5 and I have this 10 that I could combine. So let's go ahead and combine these. So if I had 2x and then I added 7x, that means I'd have 9x, right? And then I'd have minus 5. Now, if I go ahead and add on this side, all right, I have 15, and then I have plus 3x. Okay, now this might be the time to decide, okay, which ones do I want to be constants and variables? I'm just going to put a v up here, or you can put variable. Okay, but v and c you can also do as well. Okay, so I'm going to say variables are on that side, constants are going to be on this side. Okay. Okay, so if variables are on this left side of the equation, then I'm going to want to get rid of all my constants here, right? So now you can say plus 5, oops, plus 5, and then I can say plus 5. I don't want my variables on this right side, so I can say, okay, well then I'm going to subtract 3x on this side, right? So then it's gone, just like this minus 5 and plus 5. Minus 2x, but if I subtract minus 3x there, I have to subtract it from this side. Okay, so let's see what we got. Well, we had 9x and we subtracted 3x. That means we have 6x left. Okay, and then on this side, I don't have any x anymore, but I have 15 plus 5, which is 20. So that means I can divide by 6 on both sides, right? So I can do 20 divided by 6. And then if I scroll down here, then I can write my final answer and I say, okay, that canceled, so then my x is equal to 20 over 6. Well, I could simplify this a little bit and say, okay, well, a 2 goes into both of these, so then I can say this is 10 over 3. But that would be my final answer. You can write it as a mixed number if you want to, right? But for the most part, you're not going to, unless they ask for it, you don't have to. You can write it as 10 over 3. All right, so I'm going to spend a couple minutes working on some of these practice problems, and then we're going to lesson 27. So you can pause the video and then pick up after you're finished with those. All right, so let's go to lesson 27. Go back to blue here. So lesson 27. Oh, I'm going to put that up there. Okay, so lesson 27. So lesson 27 is, I think we talked about the distributive property, but this is a little bit different, but the same rules apply, but we'll say distributive property. Okay, distributive property, but this time we're talking about with variables. Okay, so distributive property with variables. Oopsie. Let's back up a little bit here, make it a little bit neater here. Okay, with variables. Okay, so before we had done the distributive property, maybe simple terms, right? We say, okay, well, we have 2x here, and then we have maybe, I don't know, x plus 2, for example, okay? So then when we did the distributive property here, we're going to take this term here, and we're going to multiply it by x, and then we'll take that term and we'll multiply it by our 2, right? So then we would end up with 2x times x, right? And 2x times x becomes 2x squared. And then we're going to do 2x times 2, which would become 4x here. Okay, so that would be a simple distributive property example there. So now if I'm going to go to something a little bit more complicated, the same rules still apply, okay? So up here, what rule did I go over with exponents? Well, we've talked about this one before. If I do x times x, what do I get? Well, I get x squared, okay? It's just like if I did 2 times 2, right? I'd get 4, or I could write this as 2 to the second power. Oops, 2 to the second power, like that, okay? So same thing applies. So if I go to example 2, let's scroll up here. So example 2, and I wrote 4xy to the third. Okay, and then I'm going to multiply it by x to the fourth power times y, right? That's what this means when I write this like this. There's a multiplication sign in there that's implied, and then we subtract 5x. Okay, so if I apply the distributive principle to this, nothing really has changed here, okay? I'm still multiplying this first term, okay? Maybe I can highlight this. I'm still multiplying this first term, so this first term is all of this, right? Multiplying that first term by this first term, and then I'm multiplying it by this second term here. So if I want to show this in all of its glorious detail, then I'd go ahead and say, okay, that's 4x to x times y to the third, okay, and then it's multiplied by x to the fourth power times y, like that, okay, and then I would go ahead and multiply this out for the second one, and I say, okay, well, there's a minus and there's a plus here, but I'm going to say minus, right, because there's only one negative sign, which means it will become negative. So then I have 4x y to the third power multiplied by 5x. Okay, so what you'll notice here, right, is that I just moved this negative sign here, right? So this is the negative sign. I moved the negative sign over here and just put it in the middle. Okay, because I know that if I'm multiplying a negative and a positive, that I will get a negative. Okay, so now let's simplify this out. So applying our rule here, right? We know that x times x would be x squared, right? So there's really a x to the 1 power here and x to the 1 power, just like there is for 2 times 2 over here. There's 2 to the 1 power times 2 to the 1 power, which equals 2 squared. Okay, so let's write out what we get here. Well, we're doing 4 here, so we can simplify our numbers first. Well, there's really a 1 here, right, before this x4 to the y. So we're just going to get 4 times 1, which will give us 4. How many x's do I have? Well, this one's really x to the first power, and the one inside the parentheses is x to the fourth power. So that means I have x to the fifth power, because I just simply add those up. I have y to the third on the outside of the parentheses, and on the inside I have y, just a single y, which means I have y to the 1. So that means I have y to the fourth power. Then I'm subtracting over here. I can multiply my 4 and my 5. So 4 and 5 multiply to 20. So I have 20. X here, I have 1x outside the parentheses, 1x in there, which means I have x to the 1 times x to the 1 here, which means I have x to the second power, or x squared. I don't have any other y's, right? My y3 is on the outside here, and I don't have any other y's, so it simply is y to the third power. Okay, so this is all I have here, really. So you could do this in one step. I showed it in 2 lines there, but you could do that in one step. You say, okay, well, this first one I have 4xy3, and the second one here, right, I'm just showing you up here in this red that I showed you there, right? Could do it in one step if you wanted to, or you can write it out in multiple steps. All right, so let's quickly do example 4, and then we'll do a maybe do one more example, but example 4. Example 4, I have 8m squared x. Okay, so you haven't seen maybe m very many times written here, but m is just like x, it's just a different placeholder. So 5m to the third power times x, and we're going to subtract 3x to the fifth plus 2x. Okay, so now you're like, oh man, this one looks complicated, right? Well, there's really not much different between our last example. This time, it's just that we have 3 terms here, right, inside the parentheses. So it's still going to be this term, and we're going to multiply it by that term, then we're going to multiply it by this term, and then we're going to multiply it by that term, okay? This arrow is still attached here, right, because we're still applying it to that one right there. So now, when I multiply this first part together, I'm not going to write it out, I don't think like I did last time, but let's think about this. I'm doing 8 here, right? This is my coefficient. So let's just underline our coefficients. My coefficients here, 5, minus 3, and plus 2. So if I multiply this first term, so this first arrow up here, then I do 8 m2 or m squared x times 5m to the third power times x. Multiply the numbers first. Well, it's 8 times 5. That just is simply 40. Okay? And then I have m squared. My m squared is multiplied by m to the third. So like we already discussed, you're just adding the numbers that are in your exponents. So m to the 2, m to the 3, we're just going to add 2 and 3, which becomes m to the fifth power. Okay? And then my x, I have an x over here, which means I have x to the 1, I have x to the 1, which means I just have x squared. Okay? This next term I have is minus 3x to the fifth. Well, 8 times minus 3 is minus 24, right? And then I don't have any m's, so that means that my m's are the same. So I just have m squared. I have x to the 1 here in this first term, and then I have x to the fifth, so that means I have x to the sixth power. In my last term here, I have 8 times 2, so that's 16 positive, right? Plus 16. And then I have no other m, so I just have m squared. And I have a single, I have a single x in both of these final terms. Right, so sorry, I'm fixing my 16 here. 16 m squared, and then I have an x to the 1 here, and then this last term inside the parentheses is also x to the 1, so that means that I have x squared. Okay, so that's my final answer right there. Right, I can't add any of these things up because none of them are the same. Have the same number of variables in them, right? This first one has m to the fifth power times x to the second power. None of the other terms over here have that same combination. And same with all these last two terms as well, right? None of them have that same combination. M squared x to the sixth, right? And this last one is m squared x squared. If they were the same, then I could combine them, right? But for now, I don't have any that are similar, so my answer is simply this right here. So you can see it's really just being careful to multiply your numbers correctly and then to add your exponents there. Okay, and I think that pretty much covers it for this lesson. So go ahead and do some practice there. Oh, there is one little part of this lesson that's similar to that, the first lesson we did, where you're going to simplify your decimal equations. So we can review that maybe real quick here. Whoops, put a line through there. So if I went to example 5, right? Example 5 has 0.4, and then we're adding plus 0.02. Okay, you might wonder why we always write 0.02. Well, if I write 0 before a decimal, it just makes it a lot clearer that I have a decimal point. So it's always a good habit to do. Okay, so and then it's equal to 4.6. Okay, we got rid of decimals in one of our last lessons here. I think it was the first lesson. So how could I do it here? Maybe think for a second. Okay, well, my 0.4 has one decimal place, 0.02m has two decimal places, and my last number 4.6 has one. So what I could do is I could multiply both sides by 100, right? And I could say, okay, that means that this is 40, so I have 40 plus 2m equals 460, just like that, right? And then I could isolate my m again, so I could say minus 40, minus 40, and then if I add those things up, then I have 2 times m equals 420. So that means that what? What's my m? Well, I can divide by 2 and figure that out, which I think you guys probably do in your head at this point, right? And you say, okay, well then my m is going to be equal to 160. Or not 160, sorry, 210. Oh, backwards there. Backwards there, and you say, then that means that my m is equal to 210. Right? Makes sense? So it's just identifying your decimal here and say, okay, well I have two decimal places here, so I'm going to multiply by 100, which would move my decimal place 2 places to the right, eliminating my decimals, making it a little bit easier to solve my equation. Okay, so now go on to your practice, and then we'll do our last lesson here, lesson 28. Okay, so 28 here. Go ahead and put it here, so lesson 28. We're talking about fractional questions here. So we'll label that. So fractional questions. Fractional questions. And I guess we can say fractional questions, and there's also functions here. So fractional questions, and we'll say and functions. So if we were to talk about talking in words, right? Because if I just say multiply, you know what that means. But if I was going to write it in words, then I can write something else, right? So if I said of, then you should know that of means I'm going to multiply something. So this is multiplication. So you say, what is half of 100, right? And you say, well, that's going to be 50, right? Because I'm going to just multiply 1/2 times 100. So that's multiply. If I see is, right? So if I say, my age is 32, right? If my age is 32, that means you could say age equals 32. So that is an equal sign there. And if I said something like what number, so what number here, you can use anything to represent what number, okay? You could use X if you want to, but we're going to start out and we're just going to use WN to represent what number, okay? And then if I have a percent, okay, whether it be 100% or 200%, so if I have some percent, let's just say I have 100%, what does that equal as a decimal? You remember? Okay, well, if we're going to change this to a decimal, we simply move the decimal place by 2 and remove the percent sign. So this would just become the number 1. Okay? So you can think of, well, if I'm eating 100% of a pizza, how many pizzas am I eating? Well, I'm eating 1 pizza, right? Because that's 100% of the pizza. And if I want to go backwards, right, and I say, well, I have a 1, okay? So I have 1, and then I'm going to convert this to a percent. Well, 1 is a percent. We just did it the reverse up here. 1 as a percent would be simply 100%. Okay, so that's a little overview of what we're going to do here, right? We're going to use what we know here about our words and convert it to math. So if I said in example 1, this is a really simple example you guys have done before in pre-algebra. I said, well, what is 3/4 of 3/4 of what number? Okay, so I said 3/4 of what number? And this is a little different because I ran out of space here. But I said 3/4 of what number? Oopsie, what number is 69, for example? And this is a question. Okay, 3/4 of what number is 69? Say, oh man, this sounds a little daunting, right, to figure this out. Well, let's just think about what we just learned up here. We said of, here, let me move this thing out of the way. We said of is multiplication. Well, 3/4 is just a fraction, right? So then if I'm going to, let's write this out in red here. I'll say, okay, well then 3/4, and if I said of, then I'm going to be multiplying, right? So 3/4, and then I said, well, what number? We could represent that with a WN, or capital WN. I'd recommend using capitals if you're going to do this. Say 3/4 of what number, and then is our equal sign, right? So we say is 69. Okay, so now we got somewhere, but then you say, okay, well, in a previous lesson, right, we divided by our number that was in front of it. This is a 3/4. I don't know that I want to divide by 3/4. Well, now we just have to realize that dividing by a fraction is the same thing as multiplying by its reciprocal. So we say, okay, well that means that, let's use just a different color here. And say, okay, well then that means that if I multiplied this side by 4/3, right, what does that become if I multiply 4/3 there? Well, my 4's cancel, right? My 3's cancel, so I'm just left with 1 here. So then I have to multiply this side by 4/3 as well, right? Which means I can put this 69/1, because if I divide 69 by 1, it doesn't change the number. Okay, and so then I have W and my what number, and I have 69. I'm going to write this out again, 69/1 multiplied by 4/3. You guys have a calculator, you guys can multiply this out as well, okay? But if I want to keep this as a fraction, I can say, okay, how could I cross reduce this? Well, 3 goes into itself once, and 3 also goes into 69. It goes into 69 23 times. So 23 times. Now at this point, it's probably easy to use a calculator, because you say 23 times 4 to make sure you don't mess up with your calculations. But 23 times 4 would be, let's see here, that would be 92. So 92. And then that's simply my answer. So my what number here that they wanted to ask about is 92. And then I could double check this, and I'd say, well, let's take my calculator. Let's do 3/4. So 3/4 would be 0.75, or I can do 3 divided by 4. And on my calculator, I'll get 0.75, and then I can multiply it by 92, and then I'll get 69 there. Okay, so that'd be the way to double check it. Okay, let's go ahead and do one more example of this, and then we'll go to a function example. So example 3. So example 3, we have this other one. They say that I have 2.5 of 240 is what number, okay? So this one, just because they wrote it out, okay, it looks a little bit different. They just said 2.5 of 240 is what number? Okay, they wrote it like this. Now let's just go back to what we know, right? We know of is multiplication. So if you have it on your notes, right, you just want to have these handy. Eventually you'll memorize them. You won't have to remember them, okay? Or write them down. But if I have 2 and 1/2, well, let's go ahead and just change that to a mixed fraction. So I know 2 and 1/2, that means that I just do 2 times 2, which gives me 4, plus 1, so it means I have 5 halves. Okay, my of is multiplication, right? So that's multiplication, and then of, right, is multiplication, then 240 is my number here. 240 I can put over 1 just to make sure I don't get confused about my multiplication. Then they said is, right? Is my equal sign. And they said what number, which I can just represent with WN. Or I could say X if I wanted to. Okay, and now I can reduce my fraction before I multiply. So then I can say, okay, well I can reduce this. My 2 goes into both of these numbers. It goes in once to 2. And over here we have 120. Okay. Now if I multiply this through, I have to do 5 times 120, so that would be 600, right? So then my what number is equal to 600. Okay, now finally, we're going to look at a function, okay? We're going to look at what a function is. So a function is pretty simple in some ways, okay? Because a function is simply, this is how I define it, it's just an input, okay? Input output machine. You give it something, whoops, input output machine. All right, so we talked about these functions before. We talked about lines before. So if I put in 5 hours of work, right, then if I get paid $10 an hour, I can put 5 hours in and I make $10 an hour. That means I get $50. So that might be like a real simple one, but if I have a function here, let's say example 4, right, example 4, and I said, well, I have x and it's multiplied by x squared, okay, and then minus 3x, and this is all in parentheses, and then you tell me that, and they told me in my example that x equals 2. Well, and see where x is in this equation over here. So what I could do is I could just plug my numbers in. Well, before I plug in my numbers, let's go ahead and solve for maybe something that's complicated over there, which is not that complicated, but we'll just say x squared, since that's one of the things to solve over there, we'll just go ahead and say that's 4, right? Because that'll make it easier for us to multiply. So then we can say, okay, 2, and then this one's 4, this one's minus 3 times 2, okay? Which means we can do, we can solve in our parentheses first. We can say, okay, that means I have 2, and then 4, this is 4 minus 6, okay? And then 4 minus 6 would be, well, if I had $4 and I tried to spend 6, what would happen? Well, I'd be in debt by $2, right? So minus 2, and then this is multiplied by 2, so that gets me minus 4. All right. Right, I worked this out in multiple steps, but I recommend writing this whole thing out, right? So write this out, write something like this out, and then you can plug your numbers in, right? Because you want to make it easy on yourself, right? Don't give yourself more work than you need, because you're going to get to the right answer if you write everything out like that, or at least more of the time, right? Okay. Last, maybe 2 more examples here. So if I did example 5. This one, they're just introducing this function here. So if I say f of x like this, really all this means here is that what's to follow is a function of x. Okay, so this just means function of x. Okay, so function of x, and then they'll say x squared minus 3x. Okay, like that. Now, you'll notice actually that it's the same thing that was written in the previous example. Okay, so there's nothing really different from this one. It's just that I'm calling it equal to function of x there. So then the handy thing about this is that if I want to specify the value of x, I can just say, okay, let's find it when the x value is 2, right? And then I can say, okay, find f of 2. Then I can plug these things in and say, okay, that means I have 2 squared here would be 4. And then I can say minus 3 times 2. Okay, and then down here I'd say 2, and then I'd say 4 minus 6. So you guys might see, right? It's the exact same thing that we just did up here, right? It's just the same thing up here. So then for my final answer, I'll just have 2 times minus 2, which is just equal to minus 4. Okay, so it's the same thing as I just did up there. Okay, last example here. Example 7. So example 7 here. This one just involves a negative, so it's a little bit harder to, or we just have to pay more attention here. So equals x squared, and then whoops, an extra mark here. Okay, x squared, and then it's multiplied by 2x minus 1. And then they gave us that, and then they said, well, what is g of minus 2? Okay, so that's kind of how you say it. Say g of minus 2, just like up here. So this one up here, they say, what is f of 2? Okay, so g of minus 2. So we're following the same method here. So say, okay, well, that means that anywhere I see an x, I can put minus 2. So that means that for this first one, I'd say, okay, minus 2 to the second power. Now I have to put these parentheses around because there's no negative in the first place around x squared, right? Okay, and then parentheses 2 times minus 2 minus 1. Okay, I'm going to close my parentheses again. Now let's scroll down, okay? Now if I have minus 2 times minus 2, that gets me a positive 4. So I can say, okay, that's positive 4. 2 times minus 2 in here, well, that's just one negative. So that means that I have minus 4, and then I still have my minus 1 here. Okay, 4 times, well, if I owe somebody $4, ask for one more dollar, I owe them $5, right? So minus 5. And then I multiply that together. 4 times 5 is 20. I have one negative sign, so that means I have minus 20. Oops, there we go, minus 20. Okay, so again, don't get confused about these g of x or f of x. They're just using a simplified notation because this notation here can be handy. It's a shorthand version of writing this one up here, right? Up here, we said x is equal to 2. Well, here, we didn't have to write those things out. They just said, what is f of 2, right? Where our x value is equal to 2. This last one, g, right? It's just simply different letters there. So g of x minus 2 there. All right, so go ahead and do your practice. And then, as always, let me know if you have any questions. And get your questions answered some way or another, okay? And I'll see you guys later.